Well, that's why they're here. There's still 9 ladies in class that are here tonight. Well, I've been following it for a long time. Didn't realize you were coming. Great. I really appreciated the Dead Sea. Oh, interesting. I never know what.
Watch when you go around the corner. It's got a computer plugged in there. Hi, Peter.
From what I heard, it's good.
Well, good evening, everyone. Welcome to this evening tonight. Here, Joel Duff speak. I'm just going to say a few words. So my name is Arnold Sigma. I teach physics here at Trinity Western, and I'm also the president of the Canadian Scientific and Christian Affiliation. This evening's lecture is sponsored by a number of groups who put this together. Their biologists funded a grant for the Solid Rock Lectures, and Joel is a speaker with Solid Rock Lectures. And we also have in this area the Vancouver Area Science and Religion Forum, which connects people between, I guess, the whole Fraser Valley, thinking about science and Christian faith. We have a number of lectures throughout the year. If you'd like to be informed about them, if you're on Facebook, you can go find CSCA on Facebook. And there's Twitter and website addresses there as well. So feel free to get connected. And if you'd like to be put onto a mailing list of events like this, of course, there's a Trinity Western events list that you can sign up for. But you can also email us at Vancouver@csca.ca. That's the Vancouver Area Science and Religion Forum. So thanks for coming tonight. This afternoon, Dr. Joel Duff spoke for about 2.5 hours over in the seminaries and addressed some interesting topics on Adam, the historical Adam. This evening, he promised to give an entirely different lecture. So Joel Duff did his bachelor's degree at Calvin College, and then he went to the University of Tennessee for his master's and his PhD. He's a biology professor, and he goes around speaking with Solid Rock Lectures. There's a couple other speakers in that group. They're both geologists, but he's the biologist that represents that conversation. Welcome, come on in. So the format of this evening is basically that Joel will speak for about an hour, and then we'll have Q&A. And we'll definitely wrap up by 9 o'clock. If we're done with Q&A before that, great. But if we get to 9 o'clock and you still have lots of burning questions, then Joel will probably hang around at the front for a little while. Then we got to whisk him off because he's on Eastern time zone. so it's almost midnight. And gather a family and friends are watching around the world. So welcome those of you who are watching on the live stream. So if you want to tweet or Facebook a message to anybody who also wants to be here, you can tell them to find the live stream on goo.gl, and then there's the address B and then uppercase WA4UB. And if people are watching on the live stream, if they want to be participants in the Q&A period, then you can tweet your questions to hashtag Duff TWU. So that's how we'll run the Q&A period. But if you're physically present in this room today, then we'll take priority for the questions that come from the floor here. So thanks, Joel, for being here today for us and for the conversation we've already had, and we look forward to another informative evening. So let's welcome Joel to do his presentation.
Well, thank you for inviting me. I've really enjoyed my time here in British Columbia so far. Despite the rain today, I was expecting the rain. I came in early yesterday, saw the sunshine, saw the mountains, and I look forward to being here a couple more days. But I really look forward to talking about God's creation. I was out there experiencing it yesterday, but I'm here to talk about it, maybe talk about in a different way that maybe you've heard about it before, and maybe show you a few new things about God's creation maybe you haven't seen before. And my whole goal here is to really create a greater sense of wonder at what God has done, at what He's accomplished in His creation. And I'm going to be spending some time talking about fossils, and that's sort of the focus of what I'm going to do. But I'm not going to start out by talking about fossils. I'm going to talk about a few other things first to get us into it here. I grew up in western Colorado, and my playground was eastern Utah. And a couple of years ago, I took my family, now that I have 5 kids, I took my family back there to show them all the places that I played, the things that I saw, the things that kind of influenced me, the things that I saw while I was growing up that made me want to become a scientist and to investigate this world. And this picture is of Corona Arch near Moab, and we hiked up there, and my family is in this picture. A little bit hard to see there. I didn't have to make it out. Right? Here we are right here. And we're standing under this enormous arch. And it just fills you with amazement at just how huge that is. I was a little bit scared. I mean, just to tell you that I really didn't like the feeling of standing underneath. I felt like it could fall at any moment. I guess I wasn't resting really in God's province there, what I should have known about it, which is it's been there for a long time. And to think that it would come on me that moment probably wasn't a very rational thought. But nonetheless, I wandered away, and I had them stand underneath the arch. So I could take a picture of them. But geology, this world, is huge. It has amazing things in it. And we can look at that and just be stunned by the size of these things. The things that this is part of God's world that we can experience it and see it. It's just huge. And that's part of what I want to communicate to you today is just how large God's creation is. And I'm going to start by talking a little bit about the size of the universe. I'm going to talk about the space and scope of the universe first. Then we'll talk a little bit about His creation of life, of organisms on Earth. And then we'll turn to the fossils and see what we can learn about God's creation from fossils. So God's handiwork, these are sort of the themes that I'm going to study, that I want to look at tonight. God's handiwork is beyond our wildest imagination. Everywhere we look, the more you probe, the more you carefully look at something, the more you see. In a lot of ways, the more you find out you don't know, and the more awed you are by it. So I'm going to talk about the breadth of creation space is only exceeded by the depth of creation in time. That's where I'm going to come with the fossils. And in a way, I'm going to try to make you feel minuscule. You don't already feel small enough. Right? Standing under that arch, you feel very small. You may feel insignificant if there's this huge world around you. But we know that we're at the center of God's creation. We may not be at the physical center of the universe, but we're at the center of God's creation. And He has a personal relationship with us. Right? We're the part of the creation that He has created and communicated with, and we can have a personal relationship with that God. And it is just amazing to think that we are able to do that inside of this vast universe that we have. God is glorified in His creation. He is glorified by His creation, by what He has created. But I would also say that we bring greater glory to Him as we look at creation and we properly attribute the things that He has made to Him. So those are the general themes. That's kind of the direction I want to go in this talk. So where to start here? I said I want to make you feel small. And there's no better way to, at first, make you feel small before making you feel important than talking about the size of the universe. All right, so this is a depiction of the relative sizes of the members of our solar system. So here we are on this little tiny pebble, right, the Earth. And we're tiny things on that Earth. Here we have the planets, and they're so much larger than the sun, of course, can't even begin to fit in this picture, because hundreds of thousands of Earths can fit into the sun. So even our solar system is a little bit hard for us to manage. It's hard for us to wrap our minds around. But our sun is but one star of maybe 100 billion stars that is in our galaxy, the Milky Way. And we're just on this local arm, right? This small arm. Not even at we're not even at the center of our galaxy, we're at the edge of our galaxy. And at the edge of that galaxy, we are sitting along with billions of other stars. And now we know that most of those stars, if not all of them, probably have their own planets. And those planets probably have moons. There's billions, potentially, of planets just in our own solar system. Of course, we can go even farther out. Powers of 10 thing, maybe powers of 100 in space. And we see that our Milky Way is just one galaxy among billions of galaxies on strands of dense collections of galaxies that are in a larger arm of dense galaxies that are part of our local neighborhood of the universe, not even the whole universe. So septillions of stars, these are numbers that I have, and I would think anyone would have trouble wrapping our heads around. How can we even begin to feel like we can understand anything about this universe that is so large? And yet, God determines the number of the stars, calls each one by his own name. He is the author of all those things. He knows the whole universe. He knows everything that's created. So in the 1500s, some rather dramatic changes happened. Because early on, in ancient man's conception of the universe, we tended to put the universe in something of a small box. I just described this massive thing. But if we go back, we see that originally we would have thought of, well, there's stars up there, right? And the stars are embedded in this outer firmament. There might not have been a concept of deep space there. It's just a shell or an area around the Earth in which the stars, the sun, and the moon are. And they are going around or evolving around the Earth. And so the Earth is at the center, right? And even the center means man really is at the center, right? Man's at the center of the universe, right? And this universe has been created for us. We can see in Genesis 1, I mean, why are there stars? Why are there the sun, the moon? For signs, and all these things are for, centered upon us. At least the description of what we should know about the universe is that these things were formed in a way that have meaning for us. So it's very natural that we would think we're at the center of this universe, but that idea was shattered with Copernicus and others after him, who didn't put the Earth at the center, but put the Earth around the sun. And to take man out of the center makes man seem less significant. Right? It makes us seem like we're not as central. We're not the core of things. So I refer to Dr. Sigmund. I'm sure he can give a full lecture on the size and scope of the universe and so forth. And so this is just my introduction to say that the universe is very large. And I think that we've had several hundred years to kind of grapple with the idea that we're not at the center of the universe. That we're sort of out there somewhere, right? We feel like we're a speck in this vast universe. But as Christians, in the Christian church, we've kind of had time to kind of get used to that idea. It's not upsetting to us. I don't think any of you in here are necessarily terribly upset to find out you're not at the center of the universe and that everything is revolving around you. You may have in the past, but now you have become used to that idea. And we have come up with ways of thinking about that allow us to have this, we're not at the center, it's okay. Our God is great. He created this wonderful universe for us. We don't have to be at the physical center of the universe, but we're still at the center with respect to, okay, He has formed us. He has created us, and we have a personal relationship with Him, no matter where we are in space. So I think what's happened is, and I think a typical view of many Christians is that creation in time and space can be described as a mile wide and an inch deep. And what I mean by that is, we've accepted that the universe is this massive thing and has billions of stars, and it's absolutely huge, right? So in terms of space, it's huge. But in terms of how long that's been around, in terms of, I just said it, how long it's been around, it's only been around for a short period of time. Right? So it's an inch deep in terms of its age, but it's miles wide in terms of its size. So let's look at that further. But before I turn to fossils and we look at a mile wide and what I can say is a mile deep, full orb view of God's creation. I want to look at what's alive today. So it's amazing to think of the stars. I'm not an astronomer though, I'm a biologist, so I naturally look at living things and I'm amazed by those. How many are your works, O Lord? In wisdom you made them all. The earth is full of your creatures, or your possessions, the things that you have formed and made. The sea is great and wide, which teems with creatures, living things, innumerable. Living things both great and small. Let's look at some of those things. Into this vast universe, God has placed us, and around us here on this earth, He has created this giant, great tapestry of other living things, other organisms. 10 to 100 million different species of things live on Earth today. There's different estimates of that, but that's a lot of species. That's a lot of different diversity of life. And most of us are familiar with, when you think of, I would ask you, what are the major groups of living things? You probably know that there's animals, and there's plants, and there's fungi, and maybe there's bacteria. That's ahead of the game there. With lots of bacteria. You know, that's our conception of the major groups of living things. So what I'm showing this graphic for is, I want to give you a sense that what you know about what living things are is but a very small fraction of the life that's out there. A very, very small fraction. Now, it's the fraction that we tend to see with our eyes most of the time. But it's a very small amount of the actual diversity that God has created. So what this represents is just the amount of difference there is in the, I'll call it the operating system that we work on. Our genome has certain things that we need to do, and all living things need to do just to survive. And if we compare that operating system, or the basic way that cells work, their biochemistry, physiology, and so forth, and we ask the question, how different are different organisms? That's what this figure is showing. It's just showing how different things are, or similar they are to each other. So I want you to focus on a couple of groups. We'll have animals, fungi, and plants. Those are the ones we think of the most. And they just represent 3 very small twigs on this general tree of the diversity of life. So let's look at what you're pretty familiar with. So there's the animals. And the animals, that little branch right there represents everything from fungi and small microorganisms that are still animals all the way up to tigers. Right? Includes all those things. What we're saying is they're all more similar to each other, genetically, physiologically, how their genetic programs work. They're all more similar to each other than animals are to dinoflagellates or the fungi or some other group. They're much more different, and so they're on a different branch. So animals, there's a lot of animals, thousands of birds, thousands of reptiles, 5,800 amphibians. There's a snapshot of some diversity of animals. And if we home in on one particular group, so let's take the birds for example, and let's look at the diversity, the types of birds. So there's a lot of different kinds of birds. There's about 10,000 species of birds, and they can be separated into various groups. Identify the groups. And let's take one particular group. So here are the penguins. And if you look at the penguins, you say, well, how many different discernible groups of penguins are there, species of penguins? So there's about 16 species of penguins alive on Earth today. And we can do this from each group. We can just hone in on each particular group and show you there's a lot of diversity of animals on this Earth. But you already know a little bit about animals. Down the zoos, you see the books, and you gotta have a feel for the general variety of animals. I want you to take you over to the other side of this diversity figure. And I'll show you the heterocons. You all know about the heterocons, right? All right, so the heterocons, you see all these other names over here, all over the place. I didn't know what all these are. Right? And some of these represent thousands and thousands and thousands of different species on each one of these. And some of them I've never heard of. And I'm a biologist. So the heterocons, the phaeophytes up there, those are seaweeds. You probably know about seaweed. You might think of them as plants, but they're so different from plants. We don't consider them plants. But I want to look at the diatoms. Right? So I'm just picking out one other group. And I'm going to say, let me show you the variety there is. The spice of life here in another group, the diatom. Those are diatoms. They're single-celled organisms that make glass houses. Right? They take silica out of the water, and they put it together in long chains. They form glass. They exude it from their body, and they build a glass shell around the living protoplasm. And they take that glass shell so it has a protective function for them. Would you like to munch on some glass? Right? And when they die, eventually what happens is that the shell is left because all the other organic material decays. And you're left with these really spectacular glass cases. And they come with all kinds of variety. There's 100,000 species probably alive on Earth. There's tens of thousands that have been named, and we know there's a lot more that we haven't named yet. All kinds of sizes and shapes, and many of these are represented in quantities of trillions upon trillions upon trillions. It's been estimated that something like 25% possibly of the oxygen produced on Earth is made by these. They're photosynthetic. They take the sunlight's energy and they turn it into sugar. And they make oxygen. And you thought trees were the only thing that did it. Right? So these are very important organisms. They're making oxygen and they're also making food for all the other organisms that are eating them. And they're extremely abundant. So here's my first fossil. So up here is shattered living glass. That's diatomaceous earth. I like to bring up this example because some people know about diatomaceous earth. Maybe they use it for a very variety of things. You may not know what it is. It's just trillions and trillions and trillions of diatoms because they die and they fall down to the bottom of the lake. They fall down to the bottom of the ocean. They pile up in these enormous numbers. And it's silica. And that's what it looks like under an electron microscope. So in that case, there's a meter that I can't even figure out the number that must be there. Right? It's like the number of stars in the sky is the number of diatoms that you're seeing in this picture. That's diatomaceous earth, and a product of that. So that's a very, very quick view of some of the diversity of life. Don't have time to go through all those other groups, but I can do each one of those and show you that there's amazing diversity. Millions and millions of different things that are alive on this earth today. So if we look at life, it seems to be this bountiful and abundant and incredible as we stare out into space. So we looked at the dimension of space, the expanse of the firmament, the works of God's hand, what we see in the present day, right? What has God made that we see here on Earth today that's alive? But there's another aspect of God's creation which I think is a little less appreciated, right? And that's His creation through time. And the way we can explore that creation is we can dig back, we can look at fossils, which are telling us something about that other part of His creation. So the fossils speak, and that was part of my title. The fossils tell us something. Maybe not always very clearly, but they are telling us something. And what I'm going to do is I'm going to paint for you a couple of pictures. So I'm going to start with some stories about particular places and things that the fossils tell us about a particular location in time. And I start with William Buckley from the early 1800s. English theologian, natural historian, greatly interested in fossils, and he was told about a new cave that had been discovered in a quarry. So they were quarrying in England, and they uncovered an opening. And he came to this cave, crawled in, and this is a depiction of what he saw. He didn't actually see the living hyena, but there were hyena bones inside. But he imagined that there was hyenas there based on what he saw. And he entered into this cave, and what he found was what he described later as a hyena den, full of rhinos, tigers, elephants, bears, and lots of hyena bones. And not only that, hyena feces. And that was actually the smoking gun, the thing that told him that these were hyenas. Because he could look at modern day hyenas, and he actually did this. Scientists in the 1800s got a hyena, took its feces, and what does it look like? You know, how is it actually, you know, what's the form of it, what's in there? And then he compared it to what he found in this cave. And there's lots of hyena bones, and there's lots of hyena feces there. And he concluded, this looks like it was a cave that hyenas used, and they went out, got prey, pulled it back here, ate it there, some of them died, left their bones there, and then all these other scattered bones of all these other creatures, elephants, bears, and hippos, the whole organism of there, just pieces of it, were brought into this cave. So this is a snapshot, this is a time capsule. Right? He opened a time capsule because there was no opening to this cave at that point. It had been covered over sometime in the past. So he opened a time capsule and was like, wow, And he's in England. He's like, I don't remember any hippos walking around. I don't remember any rhinos. I don't remember any elephants here. But he surmised that in the past, these organisms must have lived. They must have lived and breathed and been there in a natural environment, in an ecology, we would say. And in that environment at that time, there were these hyenas that lived there, and they brought those things over that cave. Now, William Buckland originally was something of the nALjrF creationist, or at least he believed the earth was old, but he believed in a global flood. And this was really challenging to him. He couldn't figure out how these fossils got in here. Eventually he concluded maybe the whole cave was there before the flood, and the flood simply covered over, just washed over this thing. But in that case, the flood didn't create all the other layers of rock either. So he couldn't coordinate all these different facts. But what he did determine was there must have been a time in England when there were rhinos, tigers, elephants, bears, and hyenas all living together. So the past was different than the present. And all those were extinct. Even those hyenas don't live today. There are different species of hyena that lives today. So I've had not such a dramatic encounter, but growing up, I grew up in western Colorado. This is my backyard, literally my backyard. 200 yards up the street, there's a neighborhood right behind me when I took this picture. I took this picture with my kids 2 years ago. When I lived there, the fences weren't there, but that was my playground. Go out there, ride your bike, pick up fossils, of course. Right? Everywhere I looked, there's fossils everywhere, strewn across this landscape. And what I found was this shell, this bivalve shell over here called Raphia. These are ammonites, these are shark's teeth. We didn't find too many of those, but they are present there. And these are crinoids. And all of these represent things that would grow in a shallow ocean. All of them are extinct today. None of them are alive today. But we all recognize that, based on their lifestyles, that they would live in a shallow ocean. What I didn't know at the time growing up, that I was looking at an ancient Jurassic, about 100 million year old seabed in my backyard, the remains of it. And it's consistent. Everywhere I went, those are the same things you find. On the other side of town, there were dinosaur bones. Was I going to find a dinosaur bone? I probably thought I would, but I really wouldn't, because it turns out the rock's a different age, and I'm not in a land environment, I'm in an ocean environment here. And this is what I found. Now, so that's an ecology, that's a unit. It's like this represents a snapshot of time when those are things that are alive there at that moment. If you go across the country, and I only found this out a few years later, the same place that I enjoyed as a child is basically represented over in England. So here we have Lyme Regis in England, a famous fossil formation, and in the lower layers of these rocks down here, you have, see that house up there? That's in the upper right corner. That's the same, essentially the same species as I found in my backyard in Colorado, on the other side of the world. And it was identified to be in the same age rock. This fossil doesn't exist in rocks that are younger. It doesn't exist in rocks that are old. There are other species and other things, but not this particular species. So it's as if on the other side of the world there was also a shallow ocean, and it had similar creatures. This says that the world at one time had oceans that all contained similar organisms living together in communities, and they got preserved in different places. The same snapshot. Same, unfortunately, we didn't have ammonites that size. In Colorado, would have loved to find the big one like that. Mine were all small. So the fossil record is 300 years of work, more, but 300 years of intensive collections of observations of things people have found from all over the world by different people with different purposes of looking for them, but writing down what they've seen. And as we have done that and collected that information together, what we found is that we find a series of different fossils at different parts of what we now call the fossil record, the geological record. I've just shown a cartoon version of that, the different ages. Some of you probably recognize things like Jurassic, Cretaceous, and so forth. That's where the dinosaur bones are found. What we learned from the fossil record, the overriding message of the fossil record is life, past life, was different than the present. What we see in the fossil record is different than today. So let me give you another snapshot. This one is even more precise and more specific. So these are plants. And what we have here is, this is a layer of volcanic ash. And this rock right here, this is volcanic ash that is hardened into the rock. So this white stuff here is all this volcanic ash. And there's a coal bed in China. And in that large coal bed of many meters thickness, where they're strip mining, they strip mine off the top layer of coal, and then there is this almost a meter thick ash layer, almost pure ash, except for fossils. And they brought in a research team. What they did was they jackhammered a whole area larger than this room of this volcanic ash. They broke it up, and then they had students go in and take every piece and look to see what fossil they found. Write down, right here, I found this leaf. Right here, I found this stump. Right here, I found this stem. Right here, I just found this binding thing. Right here, I just found a dragonfly. What this represents is some sort of forest was here, a small forest, sitting and making up this coal there. Large volcano goes off in the earth. Huge catastrophic event, right? A local catastrophic event dumps a huge amount of ash onto this forest, and boom, at one time, basically preserves that forest. What do we have? We have another time capsule right here. We have an instantaneous creation, really, of what was there at that moment when that volcano went off. And what is there is, look at these fossils. These are very easy to tell, like, what kind of plant they are from them. This is all Permian age. This is before the dinosaurs, by the way. So this is considered rock that came before the dinosaurs even existed. I just want to show you these other examples. The fossil record can be very precise. Even under a microscope, you can get down to the cellular level with these. So ash is a very good preserver of things when you get this kind of event happening. Well, what they did was, up there is the chart. There's the chart of where every tree was. So they identified the type of tree it was. Some of them had fallen down, and they had the stem, and they had the branches, and the branches connected to leaves. So now you can identify, oh, that leaf belongs to that trunk right there. That tree trunk is this particular tree. And so there's all where the trees were. And then this middle graphic is a depiction of the exact trees that were there at that moment in time when that volcano went off. Right, so we're recreating an old forest. Now this is an artistic rendition of the same thing down here. That forest looked a little foreign to you. Right, there's some tree ferns there, but everything else is very strange looking. Right, a bunch of things called lycophytes, tree ferns, there were some salamanders, frogs, insects, and essentially everything that was alive at that moment, snap, right there. It's in that ash layer. Now what's missing? There's not a single flowering plant there. There's not a single conifer. You guys know conifers? You live around conifers, right? No conifers here. No flowering plants, that means no oak trees, no maple trees. Right? That's a weird world. You can't imagine anywhere on Earth where you can go, where you can see a whole forest where there's no flowering plants, no dinosaurs, no mammals are found, no birds are found in that layer. This is a time capsule that represents, here's what the Earth was at that place in China, at that moment in time. And at that moment in time, that is what lived there, at that very moment. And that very moment looked very different than it does today. Every single one of those organisms no longer alive today. We may have a few relatives, things that are similar to them, but none of them are alive. Is that unusual? No, there's lots of other forests like that that have been observed in the fossil record. And we recreated. This one's 385 million years old, so it's 85 million years older by radiometric dating. And as you might guess, it's more simple. It has even simpler types of trees. It has less diversity than the prior one does. And that's also been back. So all those stumps there are actual positions of trees and buds. So the fossil record tells us the life in the past was different than it is in the present. And it doesn't just say, oh, there was something different there and it's kind of scrambled up. No, some of the fossil record is very precise. It says, at this point in time, there was this thing living right here. So now we want to ask the question of diversity overall. We'll say, so if the past was different than the present, how many different things have there been? How many other types of living things that we can't see today, at least alive, have there been on this earth? So I said before, there's 10 to 100 million different things alive on earth. today, species-wise. It's been estimated that there's probably been 10 billion to some sort of billion number of species on Earth. But that's like comparing, I look up in the sky and what do I see? A lot of stars. Right? And I could go in and I could kind of count and I could kind of figure out how many there are up there. And be like, I can see millions. And then you get a telescope out, I'm a biologist. So you get a telescope out and then you say, whoa, was I wrong? You know, I thought it was just a million. But now when I look out into space, I see 10 million, 100 million, 10 billion, 10 trillion. The number just goes vastly up. This is the same experience that paleontologists get when they look back in time and they look at the fossil record. Everywhere you look, lots and lots and lots of different things. So let me give you some examples of that. So start with the whales. I like whales. I've worked on whales a little bit. There's 88 different species of whales today. Cetaceans. That includes whales, dolphins, and porpoises. Those are all alive today. So I pointed out that there's 88 living things that fill the oceans today. And they live in all different environments today. They eat different kinds of foods and so forth. They fill all what we call niches, different ecological niches. But you might think, well, I know there's fossils of cetaceans, but we have 150 different named species that no longer live today, that we recognize as cetaceans. That means there's more extinct cetaceans than there are living cetaceans. There are more cetaceans that have lived on Earth that are no longer with us than we have alive today, and we marvel at what we see today. Well, I love sea reptiles, but we don't have any of them. There's over 500 named species of sea reptiles. These would be cetaceans or mammals. Forgot, right? So they have hair, mammal features. Reptiles are different, and they are found lower down the fossil record. So all those 150 extinct cetaceans, they're essentially at the very top of the fossil record. And completely separate from them, I mean, there's a whole group of other organisms which you'd be right if you confuse them with cetaceans, because they look very similar. They have similar appearances, swimming styles, and so forth. But they all are found in a lower layer of the fossil record, and there's many more than twice as many cetaceans in the fossil record of these. So let me introduce you to some of them. We hear about how dinosaurs ruled the world, and the dinosaur age, everyone loves dinosaurs, talk about dinosaurs, but at the same time the dinosaurs lived on land, the sea reptiles lived in the sea. And they filled all those environments, right? They filled all those different niches and did all those things in the ocean. And so they ruled the world for over 100 million years by radiometric dating, the geological column. And I'm going to show you each one of these. There's three major groups of sea reptiles, which are each thought to be very distinct, separate groups. We have cetaceans, we think they're all very similar. These are three completely different groups that live in the sea. Then there's our ichthyosaurs. There's 200 fossil species. More ichthyosaurs than there are cetaceans alive today. You would be wrong to think that looks like a dolphin, except the dolphin with really bad, nasty looking teeth. You wouldn't run into. And it does have similar features. It lived in similar waters, it did similar things probably. And so it took on the features that are really best fit for that particular environment. Plesiosaurs, one of my personal favorites. Over 250 species. All of these had 4 arms turned into flippers versus 2. Cetaceans have 2, so that's one of the other differences. And because they can't have enough plesiosaurs, here's another slide of the plesiosaurs. Because I think they're just spectacular. We'll especially love all the metacarpals here in the arms. And so they're just amazing creatures. I'm kind of disappointed that I can't get to go to the zoo. I can't go out and see one. I can't go down to the bay here and see plesiosaurs. It'd be great. Mosasaurs. So mosasaurs also, 100 different species of mosasaurs have been described. And remember, for fossil things, we're not done yet. We've probably only scratched the surface. There's still new ones being named every year. A couple a year, probably, for some of these groups. Because we keep looking at the rocks, and we keep finding new places to look, and we keep finding new things. We're nowhere near the end of finding the diversity of things that have lived. So There's a lot more sea reptiles than there are cetaceans. But they did live in the same environment, probably did very similar things to cetaceans did today. So one of my other themes as we come back to the end is, how could all these things have lived at exactly one time, or even over a few hundred years? Could they all live at the same time? Essentially, those animals over there lived in the same environments that cetaceans live today. If they all lived together, they would be directly competing with each other. It'd be very difficult for them to survive, I guess, in union with one another. So let's look at another group, but in this case, let's look at a completely extinct group. So some groups we still have some living remnants of today. We still have things that we can appreciate today, and we say, oh yeah, there's these, but there's also these ones that are not here. What about groups that we just don't have today at all? And it's fun to show trilobites. It's really hard to choose what I was going to show this long, because it is just like so many choices. But you can't not talk about trilobites a little bit. Trilobites in the geological column exist in the lower end of the geological column. They're not found in the dinosaurs, which means they're also not found in plesiosaurs and ichthyosaurs, even though they're found in ocean sediments. No trilobites have been found in any of those sea reptiles. They come in a wide variety of different shapes and sizes. They have 3 body parts. They're a type of arthropod, which we have arthropods today, but this was a completely different sort of lineage or group of organisms that none of which have survived to the present. So lots of different body plans, and out of each one of these sort of body plans, there's hundreds and hundreds of different variations and adaptations that they took. When I say hundreds, there's 20,000 named species of trilobites. 20,000 of them that we've already named, much less all the ones we have yet to find. So there's a lot of different trilobites. I mean, that's more than there are mammals on there. That's more than there are the number of different kinds of birds that are on Earth today. We know trilobites pretty well because they left behind us a calcium carbonate skeleton, exoskeleton. And that skeleton is pretty easily preserved. So we're not seeing the fleshy parts like you would of a lobster. We're seeing the carapace that's left. But those carapaces are quite ornate. Great eyeballs, all kinds of tiny features. Again, showing you the precision of the fossil record sometimes. Not all fossils look this pretty, but some of them can be very precise in what we can see. Love that one. It's like an alien. Trilobites probably swam through the water. Some of them crawled along the ocean floor, and some probably were underneath the sediments. And depending on the type of appendages they had so far, we can kind of infer like what kind of habitat did they live in. These are trilobite trace fossils, which is that's their footsteps right there. Right, and there are thousands of those in the fossil record at all different levels, but only where trilobites are found. If you don't find trilobite footprints in layers of rock where there aren't trilobites as well. They can get really big. Right? This one is the state fossil of Ohio, where I'm from. Or on the other side, and they're very small, well, a couple only millimeters in size. So tremendous variety, and also tremendous abundance. It's not just that we named one or two here or there. Some of these represented billions and billions and billions of individuals within a species, and they were everywhere in the world. So you can find the same species all around the world, but always in the same layer of rock, or the same age of rock, all the way around the world. Showing us that there was a time when that species lived, and it lived everywhere, nearly ubiquitous in the oceans. But then at a later time, that species didn't exist. It was replaced with other things, other trilobites, with other variations. So more variations. The eyes are great. There's lots of studies just on the eyes because you can see the calcite crystals. They had they were many eyes. Can't remember the name of it. So they had lots of eyes. And like a spider, right? Like a spider. Other crustaceans. And there's a great close-up showing the individual lenses of the eye. Okay, so, but what I want to do, which I think might be a little more pertinent now, is let's bring this up more to the present. Okay, you can see the signal.
No.
Oh, that wasn't the signal. Okay. Ken Ham in the Ken Ham Bill Nye debate showed this slide. I took this screen grab from the presentation. And in that, he was trying to make the case that creationists believe that there can be variation within times, and that you can't have a form of evolution, or that the creationists or general creationists believe that there is a good amount of evolution. Things can change from one thing to another within limits. And what he showed was cats, dogs, and elephants. And under dogs, he had there's wolves and coyotes and foxes. They all came from just a pair that came off the ark. So they got off the ark, and then they diverged and branched into all those different species of different dogs and cats. Well, I don't care so much about the cats and dogs right now. I want to talk about a different group that usually doesn't get talked about. Let's talk about the elephants. Because up there, what I noticed when I was watching that debate was, he said that mammoths and mastodons and your 3 species of elephants alive today are all just one elephant. They're just one kind of elephant that has become those different elephants. But it's a rather, I'm going to call it a slightly myopic view of the diversity of life. Right? It's a very simplified view of what there is. So here are some of the different elephants that have lived. Today we have 3 species, and we think elephants are wonderful, and they are great, and there's millions of individuals of some of those elephants today, magnificent creatures of God's creation. But we only have 3. There's only 3 species. There's 177 of them. Awesome. Some really fantastic ones. So here's nALjrF. So instead of having tusks coming out of the top, you have these tusks coming out of the bottom jaw. The jaw's kind of thrown down like this. Right? So then that's a representation of that. How about nALjrF right here? It has these scoop-like teeth at the bottom. So this is the actual fossil right here. Right? So this is a raw depiction of what it may have looked like. But right here, you're looking at the actual fossil. There's the grinding teeth up there, the huge teeth. Right? And then it's got it's pull your jaw out here, and then set your front 2 teeth out here. Right? And then figure out what you're going to do with it. So elephants come in all kinds of tusks and trunks of every variety and every sort. And elephants come from sizes of half my size to very much larger than any elephant you've seen in a zoo. Lots of different kinds of teeth. Right? There's a mastodon teeth on the left-hand side and a mammoth tooth on the other side. Right? That's a lot of evolution for those two to have come from just one tooth to have changed those different kinds of teeth. But I have to show you a couple just really interesting elephants, and maybe a couple other points of elephants. So this is nALjrF, and it's well known from the fossil record. So some fossils only know from a couple locations, maybe a couple samples. But some of the fossils we know about thousands of individuals. And it's not like they were just one of them that happened to be captured in the fossil record. There were thousands of them alive at one point. So right there in the middle up there is nALjrF, and you see how big it is. All right, so it makes your African elephant look a little puny. So a huge elephant, as it is, in case you're wondering, that is a rhino next to it. That's a hornless rhino. Probably the largest mammal to have ever walked on the land. Blue whales are the largest mammal, but they live in the ocean. Right, so they're the largest mammal. And then in the middle is the crucial feature here. That's a map of all the locations where fossils have been found of nALjrF. You see where it's been found? All the way down to South Africa, all the way up into Asia, over into Europe. And what is harder to see there is there's one in Iraq, and there's one in Lebanon, there's one in Syria, probably one in Saudi Arabia, a couple of Saudi Arabia as well. So what we're saying is there was a time in the past when this elephant right here roamed in great numbers across a great swath of the world. That's a different world than we see today. Just to reiterate the point, there's a lot of it, right? A lot of fossils. And that individual species from the past, not only was there a great diversity of species, there was a lot of individuals from each species. These are woolly mammoths. So woolly mammoths are known from the northern part of North America. They're found here in British Columbia, in the fossil record. And also from Asia, right, and Europe, or Siberia. It's estimated there's up to 10 million preserved specimens of mammoths in Siberia alone. Probably at least 15 million across the whole earth. That is a testimony to how many there are. Right, that's a picture from the 1800s from mammoth tusks that were collected just off the top surface in Siberia. Right, just walking around and picking up tusks. Right, a lot of them. Imagine 10 million of those. These are the dino hunters. I think in the National Geographic, I think about a year ago, they got a story about the mammoth hunters. The mammoth hunters. Get dinosaurs out of my mind. Everyone loves dinosaurs. I keep saying dinosaur. These are dinosaurs. So this is a mammoth tusk. These are folks in Siberia that, as the rivers erode the banks, these mammoth tusks end up jutting out the side, and they dig it out and they sell them for the item that they are. So elephants have been around for a while, and they're in a wide diversity. And if you look at the fossil record, there's also a pattern to the fossil record as well. Right? So it's not as if all 177 of those different elephants existed at one time. In fact, that's part of the problem. Could Dinotherium have lived in large numbers all across Africa, Asia, and Europe? At the same time, there was 10 million mammoths living all across the northern part. At the same time, there was 100 other species in Africa and in Europe, all of which presumably would have had thousands or hundreds of thousands of individuals themselves. I mean, they would run rampant. I mean, it literally would have just ground down the entire ground by packing it down if there were that many individuals alive in a short period of time. And by short, I mean not just like they were alive in 1 year. Even if we were to say, we'll give you a couple thousand years to live, that's just too many individuals to fit in to that short time frame. They each need to have their own time and space in which they were a community. They were individuals that were fit for that particular environment and lived in community with other organisms, but not every other organism that God has ever created all at one time. So my point over here was that the fossil record has order to it. So this little guy right here, which is very tall, it has definite elephant features to it, but very small tusks, and the teeth are elephant-like, but certainly not very as large or as developed. That's one that's kind of like lower down the fossil record. So I guess that's what gives us the impression that you have a smaller elephant with somewhat elephant-like features, and they're replaced by other elephants later in time that grow more and more and more sort of dramatic features that we associate with elephants today. So now,
it's 8:23.
all right, I can't squeeze in one last thing before getting to my main point. So let's take another snapshot of another location on Earth. I call this the lost world of South America. South America was a weird place in the past. Okay, a very strange location. South America is thought, if you look at geological maps and look at geological history, plate tectonics, that South America wasn't always connected to North America. Central America is essentially a series of volcanoes. And before those volcanoes came up and filled in that space, South America was separated from North America. And being separated meant that animals couldn't necessarily move back and forth from one place to another. They had to have a way to migrate. South America actually was attached to Antarctica at one point. It was also attached to Africa. So there was a way for animals to sort of get in South America. But South America was separated for 50 to 80 million years. You gotta think about that number. 50 million years from other continents. And during that time, it grew up its own fauna there, its own organisms that are very different than the rest of the world. There's over 1,500 different species of ungulates that are known from South America on the fossil record. 1,500, just on that one continent. Everyone guess how many there are there today? You probably count them on just a couple hands. You got some llamas, you got an alpaca. Actually, I can't think of any more. Right. Well, there's a couple deer that are native. And of course, there's some things we brought there more recently. But natively, there's not many there. So, and they're weird too, right? There you got this one with a little snout on it there. And these are just some other representations of a whole bunch of different kinds of horse fossils that are different than the horses we have today. One of the explanations for why South America was so strange and so covered up with ungulates and other grazers is that there weren't very many carnivores there. With no lions there for a long time, no bears there, carnivores, and what's some other carnivores. Anyway, not very many carnivores other than this one right here, right? Which looks very cat-like, and you might think, oh, saber-toothed cat. Saber-toothed cat is pretty common. That's not a saber-toothed cat. That is a marsupial. Okay? That's the other thing South America is known something for, is they have other marsupials. Besides Australia, South America has marsupials. That's a marsupial that has very cat-like features. It actually has retractable claws. It has this tail, it has ears that are a little bit different than cat-like, but clearly the face is a little bit cat-like as well. What about this jaw? How about that? Here's another strange one where the jaw bone has come down. And maybe that's, we don't know exactly what that's for, but maybe that's a protective function because if you've got these big long things, you don't want to be knocking on things, breaking them off. So maybe that's sort of the hold them in place when you close your mouth. But South America was a weird, strange place until something very dramatic happened. That is, volcanoes formed Panama. And at that point, lions, which used to live in North America, saber-toothed cats lived in North America, and horses and elephants, even mammoths, moved down to South America. Right? And a lot of them really loved it there, especially the carnivores. There was a lot of animals there that didn't know a whole lot about carnivores. And so the world changed at that point. And they were replaced with other organisms. Now, none of these are alive today. So again, it's an example of incredible diversity from the past, of which none of us we can enjoy in the present. My favorite one, though, is the terror birds. They maybe were another carnivore in South America. Maybe, we're not really sure exactly what the terror bird is. But I tell you, I wouldn't want to eat that particular bird in the dark out. Right? So that's a very large bird. So there's some other flightless birds. And another reason birds can be flightless there is because, again, maybe not many carnivores, not many things that would be there to give them a problem. And so it would be hard to become a large bird like that. And maybe they had these jaws or maybe they actually were carnivores themselves. There's more than 50 different species of terror birds. And that's not the only type of flightless bird that's there. All right, so incredible diversity everywhere we look. So to sum that up, I went through and I said, let's think about animals that we know, that we're pretty familiar with. And let's compare it to the past. So we've got penguins. I showed you that one. I showed you there's 16 or 17 species of penguins that alive today. How many fossil species are there? We know more than 50 different fossilized penguins species. And they are definitely a little more different than the penguins we have today. Penguins today have jointed arms, so they can't actually bend their elbows at all. So that helps them get the rigid structure to it. But a lot of the fossilized ones actually have arms that can swing out, so they might swim different. So they wouldn't look a little different to you, but otherwise they're very penguin-like in all other features. Clearly are related to penguins. Elephants, I gave you that example. We got 3 today, 177 in the past. Cetaceans, 88, 150. Rhinos, there's 5 species of rhinos today. Over 100 different species of rhinos have lived in the past, including many here in North America. Right? North America is a hotbed for rhinos. Cats. Right? Everyone loves cats. There's 40 different species of cats, and many people know almost all the different cat species on Earth. But you don't know them all. You don't know the 150 species that we know that are possible. Ancient species. Canines, 41. We have over 200 different fossilized species of dogs and canines. Bears, there's only 8 living species of bears. So far, about 63 different species of bears identified in the fossil record. And horses, a lot of horses in the fossil record. So horses there include zebras and donkeys and horses. Those are all included in horses. So there's a lot of variation, and of course dinosaurs we don't have any today, unless you consider birds dinosaurs, in which case we're still now. But there's a lot of extinct species of birds, of dinosaurs. So take home estimates. Past diversity greatly eclipses what we see today. So if you look around you and you're amazed by what you see today, and the variety of things there are today, then you've only seen a small fraction of God's creation. Right? You've only seen a tiny little portion of it. The past was different than the present. Right? Everything we imagine today, you can't import that and think, well, that's just what that would look like at any time in the past. The past was different than it was today. God's works of creation are so numerous, I don't think they can be contained in a few thousand years. God, in a sense, needed millions of years in order to express his complete creative capacity. Just like he needs, can't really say needs necessarily God, because he can do what he wants, but how has he expressed his creation in the universe? With a great expanse. With stars that we'll never see. It's so large. It's the same thing with his living creatures. He created so many of them that, in a way, they have to fill up a giant expanse as well in order to be able to fit all of this creative capacity in. Each organism had its time and space in which it brought glory to God. Now, I've had this view for a long time. I've been asked this question many times or posed this question. You know, what about an animal that lives on the bottom of the ocean and, you know, I'm never going to see it, you're never going to see it, no one's ever going to see it, it's going to live, it's going to die, and it was never appreciated by us. See, we're still a little bit man-centric, aren't we? We still feel like all of creation was made for us, right? God built this whole creation and gave it to us. So my answer had often been, well, for God's glory, right? God created these things for his glory. He didn't have to create everything just for us. It's not like it has to have a purpose for us. It's not like I have to find a use for that particular organism. It doesn't have to actually mean anything directly to me. It could just be something that God created to express himself and to bring glory for himself. And you look on it and say, look what I have done. And imagine how many billions and trillions of things that could be said about that. Imagine the stars that you and I will never see. They're beyond the reach of our telescopes, but yet they exist. So that was my sort of semi-comforting, sort of like, okay, there's just these things out there, and therefore God's glory. I'm not necessarily for us. But we've had a little bit change of mind about that recently. And just realized, I think I said all this. I'm going to move to my last slide. Right? Universe is incomprehensible. The diversity of life is also nearly incomprehensible. We might feel like we're insignificant. So, space, if you feel insignificant. I'm saying also in time you may feel insignificant. Because where are we in time? We're just a little blip at what we think of as the end of time. Right? We haven't been here since the very beginning. Right? So rather than creation is way wide and we're right here and we're a tiny speck, but at least we went from the beginning of it to the end of it. Although even there, we didn't really begin at the very beginning of it. But you know, relatively speaking, we're there most of the time. I'm saying creation is a mile wide and it's a mile deep, and we're just right here. But that's all right with me, right? Because God's creation is magnificent, and he's expressing himself in these different ways in time and space. And we have a personal relationship. So, last point. And I want you to be careful to see the small words there behind. I don't think I should have made that a little bit bold. Says speculative. Because this is my new way of thinking about the future and the meaning of what I just presented. I said in the past I would just say, oh, those things that no one will ever see will have come and gone, lived and died, are just there for God's glory, for himself. But then I got thinking, somebody asked me a question and said, you know, what are we going to be doing in heaven? You know, we're not going to be omniscient suddenly. Right? We're not going to know all things. We're still created beings. Right? We're not going to become God. So that means that we won't have all knowledge. I think we'll still be learning. I'm sure we will still be learning. We're certainly going to, and what we talk about when we talk about learning about God's attributes, learning more about His love, getting deeper into all those things that make Him who He is and how much He's loved us. And we'll learn more about that every day. I think we should expand that view to think about we're going to learn more about His creation, more about what He's done in history and in time. C.S. Lewis had, in talking about really the question of the angels, and approached this, he speculated that between the angels, who will be our elder brothers, right? They still have more knowledge, and the people are different knowledge, and the beasts who are jesters, servants, and plagiaries should expect to find parts of His creation in the end. I have this image in the background that's actually a picture from a screen grab from the Tree of Life, Terrence Malick's film from a couple years ago, which is fantastic. But at the end, he has these glorious images of sort of this heaven ethereal state. And it's sort of what you usually see, which is sort of lots of light and sort of austere landscapes. And it's all about the person and the light. Now, I understand what the mood there is. It's that we're now having a better communion with God. Right? So I'm perfectly all right with the vision he's created there. What I think is wrong about that particular picture is, I think it will be covered with variation, right? That it will be a physical place. It will be, it's still part of the creation. Well, remember, I said speculative up here, so anytime you start talking about that, you have to say speculative, because of how little we know. I'm thinking more, we're still going to be learning about God's works of creation and what He's done. His expanse in space and time will be available for us to explore. See, I've taken it from what I think is just, oh, that was for God's glory, I'll never know about it, to I might actually know about that organism. I might actually be able to see it more fully. Right now, when I look at a fossil, I am looking at His creation dimly, right, through a glass darkly. I'm imagining what might have been there, but I don't have a good vision of it. Maybe I will be able to see it in a better way in the future. In the past, we had a small vision of the universe. God just created these things, they're signs, they're right there, and we didn't really care necessarily about the organisms of the earth. They're there for, herbs for us to eat and so forth. It's kind of a limited vision of God's diversity. If it really had been that limited, and God had just made that things we absolutely need, we could have just made 2 plants. We could all just ate all those same 2 plants all day long, right? So He's a little more diverse than that. But if that had all been then, and then we were in heaven, and we were able to explore it further, our exploration wouldn't have to go very far to understand His creation. I think He's created this massive universe with such an abundant playground, we'll never be able to reach the depth of it. We'll never be able to explore the whole thing. We will always be able to find out something new about what He's done, both in space and in time. So I'm hoping that in the future, I might be looking at this weird-looking fossil, right? But I'm only looking at that through this dim glass, in which I am just hoping to catch a glimpse of what God's done. I mean, even when I look at a living thing, right, I'm still only capturing a small fragment of what it really is. I study it, and I learn more and more and more about it. I also learn how much I don't know about it. So I'm hoping that someday I'm going to be even more amazed at what He's done, and even more awed by His creation. Thank you very much.
So we've got plenty of time for some questions, and maybe you have some, and maybe he has some answers to go along with them. Okay. So I'll just let you field the questions if you like. And like I promised, we'll be done at 9 o'clock for sure. But if we're done before that, that's fine too. And if you feel other questions beyond, you might feel entertained as well. Yeah, so, and again, if you're watching online, I don't know if you're watching online, but you can tweet your questions, hashtag Duff, TWU, and I'll try to read them over here. So go ahead and ask your questions.
Yes, I presented sort of what I hope is a very positive, affirming talk about creation, rather than sort of what I'm tempted to do often, which is talk about why someone else is wrong about their view. I want to present something that makes me feel good about how I view creation and explore that. But you probably have questions about, well, there is, I've said some things in here that have other ramifications, beyond just, okay, this is great, God's done these things. How's he done? I'm fine if you have any questions. Those are easy ones to answer.
A question about extension. We tend to think that God's providence is about building up the universe, and it's good and it's beautiful. It seems that there are so many dead ends. What does that say about God's providence? Is that not problematic for us as Christians?
Yeah, and the question is about God's providence and extinction. Allowing something to die out. I'll answer this way. I think that I tried to use this word a couple times in here. I said every organism had its place and time to glorify God. Every organism, every species had its God-appointed time to glorify Him. Say, here's my expression of the genetics that I have and the different things that I am able to do. And I live in community with these other organisms. But as other organisms have explored other space and devised other things that God has allowed them to do, other organisms have found it that's appealing to them, right? They compete with those other organisms. And so when we start using the words competition and so forth, it sounds like winners and losers. But I don't think of death, I don't think of decay in God's providence and how He does things is a negative thing at all. For one thing, we're not talking about moral creatures. We're talking about organisms that are following some kind of path by which God has given them the ability to express something through their genetics. And it's not a lot different than, look at that great arch I showed you. That arch is not always going to be around. Someday it's going to fall. And I'm not going to be able to appreciate its beauty after it falls. But that arch has a certain time and place. And the beauty of that arch is that new ones are forming right now. Off to the side in that same picture, there's a huge hole being excavated at the side of that hill. And eventually, as the other material erodes behind it, it will probably become something like a new arch. And it will have its place in time. And we'll forget about that prior arch. Because I'm saying, I'm hoping to see all the arches God's ever made. At some point. Yeah.
Would you say there's a blend of all creatures were in the timeline of each and every thing?
Being the strong Calvinist that I am, there's always a tension among Calvinists about it. If you're hyper-Calvinist and everything is predetermined. So that's the tension we always ride with is whether everything is scripted. I can't. God is in control of everything. But if God is in control of everything, is there anything like free will? That's going to be a really difficult conversation. But my answer would be that it's actually no. It's not all predetermined. Other than God does guide and direct everything. And I do believe that God is outside of time and space and sees all things and knows all history. Knows all history as it happens before it happens at the end of history. So the way He is in control of all that. But I can't answer the question of free will, how that works with organisms over time. But I don't see individual organisms as they have a point in time in. I can stop there before I get dig myself a deeper hole.
In fact, on that point, I'd suggest that what he showed actually challenges that notion of omniscience. That in fact, even God needs to explore stages, so from simple to more complex organisms through whatever processes achieve that.
Yeah, I think what I presented would be like out of, let's say, open theism.
Yeah.
And I've read a lot of open theism, and I'm sympathetic to some aspects of that. I'm not giving up on my Calvinism, but it's something I have to think about. And this is the type of thing that makes you think about those issues, right? It's this kind of data, it's these kind of things that we think about that really do force us to ask those really difficult questions of ourselves about how exactly does God work in this world?
To ask a more practical question, all these extinctions and all these transitions and many species, what are the most dominant mechanisms for extinction? I mean, we hear a lot about asteroids and volcanoes and things, but are those really the dominant mechanisms, or is it just this constant turnover?
Well, okay, that is actually a very good question. Because there's no simple answer for that. So depending on which paleontologist, or whether you talk to a paleontologist versus you talk to maybe a molecular biologist or a neo-Darwinist, or there's different areas of biology. People have different views about what actually is the most important mechanisms of evolution. Is it selection? Is it drift? Is it, there's the neutral evolution. There's all these different types of mechanisms. And depending on which one you think is one of the more important ones, may skew your vision of how you think things go extinct. But you back away from that for a second and say, extinction is still very important. Whether it is the overriding factor, there are certain people who have written about that extinction is one of the things that really focuses big changes. So that there is relative stasis in which things aren't changing very much, and all they're doing is they're taking a body plan or a pattern, or like a trial of life. They're saying, yeah, let's add a little thing here, let's change the eye a little bit, but we're not changing into something radically different. In order to do that, and this will give away a little bit of my view, in order to really make a dramatic change, you have to have a new landscape in which you don't have competition and you can explore new ideas. Organisms explore new ideas. So when something gets wiped out, so a whole bunch of organisms die, and all of a sudden, hey, I don't have any competition anymore. You can try out new plants. You can try out new properties. I've got these genes. I had 3 mistakes. In the past, if I had made a mistake, I would have been dead because I wouldn't be able to compete with this other individual that was doing something very similar. That individual over there is no longer alive, right? It's gone extinct. I now have this mutation, and although it's not the best mutation in the world, it allows me to do something a little different, which allows me to work in that habitat over there that one occupied. So now I can go live over there. And it also allows for more radical changes. So what you see in the fossil, I think what a lot of paleontologists say is what you see organisms are changing a little bit, changing a little bit. All of a sudden there's like, global extinction where 40% of all organisms go extinct. There's global ice age, there's a giant comet, there's a variety of catastrophic reasons why that might happen. And that sort of resets everything. At that point, all of a sudden the organisms that manage to survive get to play on this new playground. In which case what you see, and this is what you see in the fossil record, you see all of a sudden, boom, 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 a whole bunch of new things are formed. And then you see, oh, they all kind of sort themselves out and now they kind of don't change very much. And all those organisms, they're kind of waiting for the next reset. And the next reset is, hey, everything on Earth kind of got scrambled up again. Now everything has to figure it all out. How do my genes work with your genes? How am I going to associate with you? This carnivore no longer exists anymore. Well, now I don't have to actually make that spiny shell because there's no one bothering me anymore. So I'll go do this other thing. So all life is really adapting to other life all the time. And so the more dramatic the changes to other living things, the more dramatic the change you can make during your life. And so just to add a little bit broader perspective on that, I see God as preparing the earth for us. So I do see ourselves as being in a special place at a special time. I don't think the earth that had dinosaurs and these huge terror birds was the place for us, right? It did express his creation, and it is for his glory, and maybe someday we'll be able to appreciate it. That's what I'm hoping, even more. But the place we're in right now, I am confident, is the place that's for us. That is what he has prepared for us. There's my comments. Yeah.
What does the fossil record say about transitions between nature and elements?
The fossil record says that almost all animal groups that we think of as being major animal groups have a pretty good fossil transition record. I know that that's not the public perception, but often that is wrapped up in the definition of transitional fossils. So like that elephant there. I showed a little elephant, and it had like these little tufts, and it actually had feet that had separate toes that were slightly fused, but not in a complete patch like you'd expect with an elephant today. So when you go back in the fossil record, you find that the farther you go back, the less and less and less and less elephant-like the features are. And then at some point, you're going to have to say, is that really an elephant anymore? So we tend to put packages on things, right? We call something an elephant versus it's something else, right? That's because we need discrete boundaries, right? That's not what the fossil record is. The fossil record is not a bunch of discrete boundaries. It is lots of populations that are gradually changing, and at some point, you can't decide, is that really this just variation in their population, or is that two different species? Is that two different species, or is that two different genera? Is that we define things, and because we define them, it sounds like, oh, there's elephants, and there's these other things. But when you look at those elephants, somebody has decided that's enough like an elephant that I'm going to push them into the elephant group. But if you'd like to see it as a transitional fossil, it is a transitional fossil. It's a transition from an even smaller animal, right, that didn't have tusks, but it had feet. They were lived in an environment where it was ready to be adapted to that elephant-like thing. In other words, it wasn't very far from that to that little tiny elephant that looks like what we call an elephant. But 500,000 years earlier, it didn't look like that, and you even look at the fossil record, you're like, oh, that's not an elephant, right? But we just don't recognize that that is the thing that came right before that elephant. So it's just hard to see the transitions because of the way we define them sometimes. But for most groups, we have a lot of good transitions. Now, I'll admit, for like trilobites just sort of show up in the Cambrian. Pretty much the way they look. We don't have a really good example of something that's like before a trilobite. But then again, that's 550 million years ago, and our fossil record isn't quite as good. And the farther back you look, the harder it is to infer. But that's why I like the elephant example, because we have recent stuff with that. You had a follow-up, so I want to get to you first.
You see the trilobites show up, that's part of the Cambrian explosion that we don't expect.
Well, yes, but even in the Cambrian explosion, I don't think that things just show up. You know, I just use that word, just show up. But even in the Cambrian explosion occurs over 50 to 70 million years. That for us in fossil records, it is just showing up because it's a blip compared to the entire fossil record. But if you think about it, I don't know about you, but a million years is still a long period of time. You know, but in terms of how fast things change, that's a lot of change that happened in the Cambrian explosion. That's a lot of things that changed. What we think is being fairly quick. Now, Ken Ham says that two animals can get out of the ark and become 177 different elements. So for him, I don't think the Cambrian explosion is a big deal. Things happen like that. It easily happen. So it's a matter of scale. There was another question. I don't know.
Well, this is your topic, but it's very common. But that's related to the Cambrian explosion. It's TJ Will's preferred exposition on the British shale.
Yeah.
Like, slow down the book. Right? And for example, if you rewound the tape of light,
Would you get the same thing as the question you asked? Yeah.
So I'm curious if your thoughts are on it. You know, and especially again, the dating I space and
Yeah, I think. Yeah, the idea of contingency, or that you carry certain historical characters. In other words, an elephant can't become a cat. I mean, that's a simple example. Right? It's not going to change into a cat. It never will. Right? It already is on a trajectory. It has certain programming genes that work together in a certain way that make it an elephant. Now, that elephant, look at that little elephant and what it became, an African elephant and a dino period, ones that had tusks on top and the bottom, ones that had tusks that curled around, ones that had different, I mean, it turned in a lot of variation. And some of those elephants, 5 million years from now, you might like, make sure that's an elephant anymore, right? It might come into a different area, but it's not gonna become a cat. So its programming has sort of shunted it in one direction. So part of the answer is that for some groups, if you rewound the tape, some of their programming is such that they can only explore so much we call genetic space. There's only so much programming area that they can explore. So an animal can't become a plant, and I can't become a bacteria. Those are obviously over dramatized examples, but they get the idea across. And so even in smaller groups, I'd say that this organism only can become these number of different things. Now, I can't even imagine the amount of variety they can become. That variety is all going to be different than what would come from some other group. Now, all that said, there's a lot of research being done lately to try to figure out exactly how much there is sort of at the programming level that allows different organisms in different landscapes to come up with the same ideas. We call that convergent evolution. So can two different organisms living in two different environments, well, I kind of showed one, didn't I? All right, that marsupial that looks like a cat, right? So there's a marsupial that gave birth to, what marsupials do, they give birth, well, that one doesn't have a pouch, but there's a whole different, life habit. And it looks a lot like a cat, but if you go through every feature, and if you were to go inside though, and you were to ask, how did it make that tooth? How did it make that fur? How did it make those claws? You find out it has a whole different set of genetic programming. A whole different set of genes that make that same feature that looks very similar to that saber-toothed cat. But externally, they derive the same characters because for that environment, it turns out saber teeth really work well when you're trying to capture a nugget. And having claws really work well when you got to grab onto its neck. And so those features are advantageous for that environment, but they're derived in different ways. So I think nALjrF even today was, if you were still with us today, would probably admit that we can get many similar features, but sometimes we get to them in different ways.
So perhaps this will be our last question then. Okay.
I'm not sure this. When it comes to fossils, when something's like preserved in the ground, is sorry, I should know this.
That's right.
As a carbon or something, can it be distorted? Not in what we actually see, but like in size or shape. Like, can we be sure that say a T-Rex was actually that big, or rather that it affected rock around that area, and that in effect was like blown up, or shrunk by the processes of geology and rocks around it?
Absolutely. Fossils are always, that's part of the reason why I said, everything we're looking at is looking through that glass is somewhat different. Now, some fossils are more clear than others. Some of those plants I showed you, if you can get down to the level where you're seeing the individual cells, then those probably aren't distorted very much. Those are the cells, and that's about the size they were, and so forth. Some fossils, though, can get very compressed. Some things get very flat. So sometimes we're recreating, what did that thing look like in 3 dimensions? And so there are assumptions involved. Well, I assume it acts like this because this happens today. T-Rex, the reason I would say we know that T-Rex is that large is not the reason we know is because we have a lot of T-Rex fossils. So you could say that one fossil, maybe there were special conditions that allowed for when it got squished, the bones got elongated. Right? So I'm overestimating the size. But then you ask yourself, well, what if I found those same kind of fossils in 5 different rock formations that were made in different ways under different conditions, and they're all the same size? Well, then you have a rational argument for saying, okay, that argument worked once, but I can't use it 5 independent times to explain away something where there's a more obvious explanation, and that is they really were that size. I like to use the example of why did T-Rex have little arms? Right? How do we know it had two little arms? Right? These little things. What were they doing with those things? Right? And if I told you that for T-Rexes, I looked and I couldn't find more than maybe 2 examples where we actually have like a T-Rex skeleton laying there. which you can see the rib cage, and boom, there's the arm, and you see the arm about connected. And actually, the bones are never completely connected because the cartilage between it is eroded away. So you have the bones laying there. You could ask the same question: how do you know that bone really was with that bone? Sure, I see it next to it, but it could have just by chance been put there or moved there and resorted there. But once you've seen a whole bunch of them in the same position, your confidence grows that, oh yeah, okay, that's what's happening. Now with T-Rexes, we only have a couple T-Rexes. Like Tyrannosaurus Rex, we only have a couple of them that have a few arm bones, and they're short, and we don't have the entire arm. I'm not sure we have a complete arm with every single bone. So how do we know we had short arms? Because we know of lots of other species of Tyrannosaurus. Tyrannosaurus Rex wasn't the only one. There was other ones, and there was other theropods, ones that walked on 2 legs and had 2 front legs up high. And you'll see pictures of them, they all have short arms. That's because for all those other species, almost every one of them has fossils with short arms. And for some of them, we may only have one bone, then it's all it takes. You're like, oh, that's a short bone right there. Well, all the rest of the bones are probably just like that because they're just like all those other 100 species. So once you've seen hundreds of species, and like the alternative explanation is that maybe T-Rex was the only one that was different. And then you ask, what's the chances that it was the only one that was different when every other one you found was the same way? So the fossil record is something that we infer, and we have the bones, and I like to say they're the facts. But you still got to put the bones together and derive a picture from it. And our pictures aren't always facts, but they can get really close to being rationally very reasonable to believe that that's what we're actually seeing those recreations of. Because the alternative explanations become very weak once you put a lot of bones together. That's a long-winded answer for the last question. Hope that helps.
Okay, well, let's thank Joel once again. Thanks for guiding us through the space and time, the past, and even to the future, perhaps. That's speculation, so thank you. All right, well, have a good evening, everyone, and maybe we'll see you at some other event we have in the future. I expect we will. Stay in touch.